Logical vectors are a powerful tool within MATLAB for finding and selecting subsets of arrays. Chapter 5 in your textbook goes through the details, but I want to give you just a brief introduction to the concept. So let's start off by creating an array of Gaussian random numbers. We'll make it a row vector with 6 elements. And let's say that we want to do some finding of certain kinds of elements. So if we simply enter the statement a greater than 0, and you say, well, what does that do? Well, take a look, and what happens is that it's actually evaluating every element in the vector against this statement. So is 0.5 greater than 0? Yes, it is. So we get a 1 in the logical vector. Is minus 0.4 greater than 0? No, it is not. So we get a 0. So the result of this expression is a logical vector where we get a true if the statement is true, we get a false or 0 if the statement is false. Now, this logical vector can then be used in order to create subsets of arrays. So for example, I could say I'm going to set B equal to A where A is greater than 0. And if we enter that, and you see that we get a vector B, and its elements are equal to the elements of A that were greater than 0. Now similarly, obviously, I could say that C is equal to A where A is less than or equal to 0, and that is going to give me the other 3 elements in the original array A. Now I can also just create a new A out of the as a subset of the old A, but then the original A would be destroyed, and so that's why I'm setting it equal to B and C in this case. So it's important to note that there's nothing magic about this particular evaluation criteria, greater than or less than or equal to 0. There are and any other logical expression you could put in there is perfectly fine. So for example, we could say that D is equal to A where the absolute value of A is greater than let's say 0.5. And when we do that, we see that we get the first element of A, which is greater than 0.5. We get the third element, which is greater than 0.5. We also get the fourth element, whose absolute value is greater than 0.5. And the other 3 elements then do not meet the criteria and are not in there. Okay, so this gives you an idea of how you can pull out certain elements within an array depending on the criteria of your choosing. But let's say we don't want to create a subset, but rather we just want to find the location. Specifically, we want to know the indices of certain elements within an array. So for example, under this criteria, let's say I don't want to create a new array, but I want to know the indices of A, of the elements of A that meet this criteria. Well, for that, the easiest thing to use is the find statement. So we can pull up, I'll use the up arrow key in order to pull up that previous value expression. And what we'll do now is we will simply say find the elements of A where the absolute value is greater than 0.5. If I hit enter, it informs me that it's index 1, 3, and 4. So the 0.5 was at index 1, the 1.12 was at index 3, and the minus 0.69, which met the criteria, is at index 4. So that allows you to find the indices of those elements without creating the logical vector. Just gives you those indices. These techniques also work on matrices, multi-dimensional arrays, as well as single-dimension arrays. So, for example, if I say that E is equal to magic 3, so I get the 3 by 3 matrix, and if I then say, well, find those elements where E is greater than 5, then it gives me a linear index, and that's where it starts off the 1, 2, 3, 4, 5, 6, 7, 8, 9. And so 8 was greater than 5. These two are not. That's not greater than 5. However, 9, 6, and 7 are all greater than 5. So that was 1, 2, 3, 4, 5, 6, 7, and 8. And so find gave us 1, 6, 7, and 8. And you say, well, that's fine, but what I really wanted to know was the row and column index. Well, you can do that too. You just have to tell MATLAB that's what you want. So if you say, for example, row index, column index equals, and so then we see that the first one is 1, 1, the second one is 3, 2. Let's go back and make sure. So it's the third row, second column. Yep, that's right. And the third one was first row, third column. First row, third column. Yep, that's 6. And then the last one was the second row, third column. So second row, third column, 7. Yep, and that pulls that out. All right, so you'll get a chance to get into both the use of logical vectors and specifically the find function in more detail in Chapter 5, and you'll get a chance to get some practice with this in your homework.